Today we have Dr. Leanne Ketterlin-Geller, who's an associate professor and director of research in mathematics education at this university in the United States, and she's presenting on the technology of early grade mathematics that are used in. So with ado, I'm going to hand it over to her, and she will start the webinar.
Great, thank you very much. And I'm very pleased to be here this morning here in Dallas, Texas. So I'm hoping to talking about evaluating the efficacy of early assessment. And the purpose that I'd like to talk about today is that as we evaluate the technical adequacy of early grade mathematics assessment, it depends on the purpose of the test. And as this analogy with an iceberg indicates, that the evidence that supports test use really needs to be strong enough to make different decisions that we might be wanting to make from the results of any assessment system. And what we'll be talking about today is early grade mathematics assessment. So the two uses I'm going to focus in on today, uses of assessment results and summative uses of assessment results. And the formative uses are to guide decisions. So uses might have to help support the decisions that they make in the classroom to help support the learning process. And then summative decisions, as far as programmatic decisions or the results being used to inform stakeholders about students' general proficiency in early grade mathematics. And so the evidence for the validity of either of these uses depends on the evidence that we're going to be collecting and evaluating really depends on the uses and whether you're going to form an assessment system formatively or formatively. And so as Deepa mentioned, we'll be talking about and sharing evidence from the early grade mathematics assessment system and as we look through these different assessment systems. But the discussion today will really be grounded in the International Testing Commission's guidelines on test use. And they focus in on how the test users need to, the purpose of the test and the reason of the test, the reason for administering the test as they're evaluating the technical documentation. So in their guidelines, which can be downloaded from the website, the guidelines focus in on, there's section 2.2.2 focuses in on evaluating technical documentation. And they have 6 dimensions in which they recommend evaluating the technical documentation. And today I'll share information or evidence for the first 3, and we'll talk about those first 3. And as I mentioned, that will be in the context of the EGMA or the early grade mathematics assessment. So the first is the scope or coverage and representativeness of the test content, the accuracy of the measurement and reliability of the results, and the validity and relevance for the required use. And so we will situate today's discussion in the 2 uses that I mentioned and look at the evidence for the early grade mathematics assessment in these 3 areas. So as we go to the evidence that supports test use under the tip of the iceberg, the first evidence that I'd like to talk about is section in the guidelines 2.2.2a, and that is the scope or coverage and representativeness of the test content. And the test content obviously influences the conclusions that can be drawn from the results. We say that and it's, as I said, it seems obvious and apparent, but when we're looking at making different decisions based on the test results, we may want to be looking at what the content, the information that's in the test and how that content can influence those decisions that we want to make. So some questions we can ask of the test is what content to make the test, at what proportions or different domains within the content or different areas within the content domain sampled, and at what levels of cognitive complexity or cognitive engagement are students being asked to engage with the content. And so levels of cognitive complexity could include conceptual understanding, procedural understanding, maybe the reasoning or strategic use. So there's several different taxonomies of cognitive complexity, but it really references how students engage with the content that's being assessed. So we'll look at the two different uses that we were talking about: formative instructional decisions, using results to make formative decisions, or using results to make summative programmatic decisions. So when we're looking at making formative decisions, because this information will be used formatively to guide teacher decisions in the classroom, we want the content to be instructionally actionable, so that teachers can take that information that they get from the test, use it to change instruction with a support improving student achievement. So we want to see a narrow range of content that is sampled, so that the information that's presented back to the teacher is fine-grained about what students know and are able to do. And we could include varying levels of cognitive complexity in the assessment, but it would really depend on the instructional goal. So for example, it might focus in on conceptual understanding, if that's related to the goal, the instructional goal that the teacher is hoping to make a decision about, or procedural fluency, or perhaps reasoning, or their ability to use strategies. So in looking at the content from the early grade mathematics assessment, this is an example from the EGMA. This is the number discrimination task. And so what this table shows you is there are the columns. This is from the assessor manual. And so the first item is where the student looks at 7 and 5 and points to or says the number that is greater. And then you can see it moves down to 11 as compared to 24. And there's 10 items in this sub moves to the last is 867 to 965. So this is the scoring guide. So you can see that students are scoring 0 or 1. And this assesses one dimension of numeracy, one dimension of students' understanding of number, and it really is in on their understanding of magnitude. Teachers can take these results and dissect this information and really help guide their instruction on students' understanding of place value comparisons. And so in the utility of this assessment, we could look at how teachers can take the information, even scored 0s and 1s, and understand what might be students' errors or misconceptions as they look through patterns in students' performance. So this is a narrow sampling of content that might help teachers make more informative decisions for their instruction. So as we move to the other use of assessment results, and in this case talking about early grade mathematics assessments, we often see that these assessments are used to make programmatic decisions or to inform stakeholders about students' proficiency. And if we wanted to look at those uses, we need to look at different content sampling. So we would want to assess broader skills, perhaps, but really that they align with the curricular expectations. And those are typically set out in the standards for the grade or the age range. And so the content should be broadly sampled so that the uses or the information that's provided back really can help the interpreter, the test interpreter, draw conclusions about students' proficiency across that broad range of content. And we would want to assess varying levels of cognitive complexity unless the curricular expectations very narrowly focused in on any dimension of cognitive complexity. So as an example, if we look at the EGMA, and previous presenters at this webinar series have talked about indicators of numeracy, but if we look at the EGMA generally, across the subtests, which are listed in the second column here, it broadly samples across numeracy and the indicators of numeracy. So together, these different subtests would support these summative assessment decisions that would help inform stakeholders or the test users about a broader range of numeracy skills and knowledge, student skills and knowledge in numeracy. Okay, so that was our first look at some of the validity evidence we needed to support the test and the two different test uses of assessments that we often see. So moving to the next, we look at 2.2.2b, and this is looking at the accuracy of measurement and reliability. And the accuracy of the measurement and reliability influences our trustworthiness of the results for making either of these two decisions. And so we'll look at these two decisions and the standards at which we want to look at the evidence to support these uses. So for formative instructional decisions, it is acceptable to have reliability estimates of 0.7 because formative assessment decisions are considered to be low stakes, meaning that these are used to guide teachers' instruction, but there's many different data sources that are informing teachers, and as teachers implement the decisions or the outcomes that they've made based on their interpretation of the results, they can make corrections. So if they do see that there's an error in their decision that they made, it's easy to change their instruction as a result of that observation. So the 0.7 is considered. So, these are a sample of a little bit over 5 students with the early grade mathematics assessment, and you can see that the 5 subtests of the EGMA meet these criteria of having a reliability of above 0.7. So these would be considered to have consistent results in which teachers might be able to make formative instructional decisions. So if we come to the summative assessment decision, summative programmatic decisions, reliability of 0.8 is considered acceptable for high stakes test uses because we want the results to be consistent, have confidence that those are consistent. So when we look at the EGMA subtest data, we see that there are 3 subtests that meet criteria. So it's the number identification subtest, the addition level 1, and subtraction. All meet the criteria of having reliability of above 0.8. Okay, so again, just coming back to the purpose of the discussion, we can see how looking at the technical adequacy data really depends on the uses that we have for the test. So this to show that regardless of the test use, that there's some overtions that we want items, as I said, regardless of test use. And one of those is that the item to total correlations should be between 0.3 and 0.7. And this is an indicator of the internal consistency. It's an indicator that the items are related to each other in an important way. And also that the items have acceptable fit statistics with the model. And this is important in whatever system that you're using, but I'm specifically looking at the Roche item response theory modeling results. And there's specific criteria for interpreting those results. So if we look at the EGMA subtest, this is a number discrimination subtest. And again, it's just some samples of data to help illustrate the importance of these concepts. So if you look at the same content as listed on the left column, similar to what we presented in the previous slide. And then on the far right column, it's a PTME. This means point to measure. This is the item to total correlation. And you can see that, that all of these items have acceptable item to total correlations in that they range between 0.3 and 0.7. There is a few that go above 0.7, which means that those might be assessing similar content, but they really are acceptable. If you look at the 2 middle columns, this is an indicator of the items fit with the model. And these data should be between 0.5 and 1.5. This indicates that the data are predictable for these items, and all but one item fits with the IRT model, the Roche model in particular that we're using here. So the very first item, which is 7 compared to 5, where the student is identifying which is greater, it doesn't fit the model very well, which means that it's not very predictable in that students will, some students with high ability may be missing this item. Some students with low ability are likely getting this item correct. This is an item that is not very difficult. So there's some other explanatory factors that could go into this, but really the point of this slide is to show that as we're looking at these evidence, we want to be looking at a variety of different data to make either decision so that we can really verify that the results are reliable over time and consistent over time. So moving to the last indicator of technical adequacy, we'll look at 2.2.2, and that's the validity and relevance for the required use and the sufficiency of the measurement system. So we want to be able to make decisions, formative decisions or summative decisions, and the distributions across the range of ability level really influence our ability to detect differences in students' mathematics knowledge. And we also want to look at the relationship, the results with other variables to help us evaluate the trustworthiness of the test for making the decisions that we're wanting it to make. So when we look at formative instructional decisions, we want a range of item ability estimates to be narrow, to focus in on specific content. And this is an example. This is a right diagram, and this is an output from the Roche model. And anyone who's interested in talking about these results in more detail, I'm happy to talk about that. But I just wanted to illustrate what this looks like. So on the right side of the diagram, this is the distribution of items and item difficulty across the scale of students' ability. And on the left column, you'll see there's hashtags or dollar signs, and those are the person ability estimates. And so you can see this is not, this is an example where there's a clustering of items in the number identification subtest that's just below 0, which is the mean. So this is narrowly targeted test that's slightly below the mean. You can see there's mode that's ethics, and so that indicates more difficult items, although this is a test, so there's some implications there. And you'll see that there's a person mode at around 3. So this subtest would not necessarily target students with more advanced ability in number identification because the mode of the students does not necessarily match up with the mode of the. But I wanted to illustrate to you how you can look at the evidence to help make some of those determinations and to see if the range of item abilities really is targeted to where you'll be making some instructional decisions. So if we move to talking about summative programmatic decisions, we want the items, since we'll be assessing all students, we want the items to represent a range of ability levels or have a range of difficulty estimates as well. And we want the information to be maximally informative from the test at the mode of the person ability estimates. And so this is a test information function, and this happens to be for addition level 1. And you can see that the peak of this test information function is right around 0.5, between 0.5 and 0.1, and excuse me, 0.5 and 1. And that means that this subtest is maximally informative at this point where students have an ability estimate of around 0 to. So if we saw the mode of student response was off of this, this peak, then the test wouldn't be well targeted into who are taking this subtest. So again, this is evidence differences that we would want to look at, evidence for adequacy based on the uses of the assessment systems. So what you have in common, what all tests should share, regardless of the decision that you're trying to make, is that the correlation with similar content should be strong. We want to make sure that we're measuring what we consistent content. and that the correlations with different constructs should be weak so that we are not measuring something that might be competing, a different construct. So when we look at the correlations between the EGMA subtests, again, this follows a similar color coding where the pink shading is evidence and the orange shading is correlations. You can see varying degrees of correlation between these different subtests and how we can use this information to help decide which subtests might be maximally informative for either instructional decisions and or summative programmatic decisions. And then finally, looking at between the EGMA subtest with fluency. So again, evidence for validity. I want to make sure that we're not assessing another of students' understanding. In this case, I picked an indicator of reading fluency to look at if there's something about the items, the mathematics items, that may be targeting reading, for example. And these correlations are relatively weak. So this provides evidence that we would be able to make those types of decisions and not be basing that on reading scores or reading ability. So the purpose of today's assessment was really just to provide an overview of technical adequacy information and using that the EGMA as an example to illustrate that the evidence that we collect and the way that we evaluate the evidence does depend on the purpose of the test and giving us evidence for test use. So I am happy to answer any.
So much, Leanne. That was a great presentation. Has any questions, feel free to chat box. One question from Davis. He says, Leanne, this is great. Would you be interested in doing another presentation that addresses the other three for evaluating tests? Bias, fairness, and practicality. We deal with these issues quite a bit as well.
Absolutely. I think that's a very important component of test validity and evaluating the technical adequacy. And certainly the International Test Commission recognizes that as well and has those as the mentioned. So I'd be happy to talk with you.
Okay, great. Are there any? Sorry, Leanne, I'm just waiting for people to type it into the chat. Okay, looks like definitely arrange for another presentation, another webinar present to address the other three areas of evaluating tests. Yeah. I apologize. There's a little bit of a delay when people type in the question. I see someone is typing a question in. Okay. Ann Sellers has a question. She works at CRS. She says, maybe this is tied to Jeff's points, but is there ever screening for dyslexia as a first step in testing? And she also says, great last slide, by the way.
Thank you. Depending on the use of the test, then it certainly could be important to screen for students to make sure that we don't have any sources of construct irrelevant variance that are impacting the results that we might get from the assessment system. And so for some students who may have, for example, you mentioned dyslexia, we would want to make sure that we were providing an assessment that perhaps had appropriate accommodations that would allow us to get at the targeted skills as opposed to any of the student characteristics such as perhaps what characteristics might be impacting their ability to interpret the test as they're taking it based on dyslexia. So those accommodations could be provided to a test as long as it didn't change the construct of the test what the test is measuring. Put that thought at your question.
Okay, thanks, Leanne.
I'm sorry, I'm getting a little bit of feedback, so.
Okay. She's writing back. Hold on one second. Okay, I think it addressed her question. She's writing something back. Does anyone else have any other questions?
I'm also more than happy to answer any emails if anybody has any questions. I know I went through some of the technical information relatively quickly, so please feel free to email me.
Okay, great. Thank you, Leanne. What I'll do is I'll send your presentation as well as this video out to the community of practice. Okay, so Anne has written back. Hold on one second. She says, yes, the feedback is terrible, but I understand your answer. Thanks. I just think that in many developing countries, screening isn't done regularly, and I'm wondering how this might impact the testing results.
I believe in what Jeff was mentioning, some of those other indicators, such as the consequential aspects of the validity. If we identify a student who, in the EGMA, for example, as having maybe perhaps lower ability in mathematics, but really they did not have adequate access to the test because of personal characteristics that were not related to their mathematics ability, then we're making an inappropriate decision based on their mathematics ability that was based on some form of other characteristics, such as for students who have dyslexia, if there's an interfering mechanism that prevents us from getting accurate measurement of their mathematics knowledge and skills. So, and I think that's an important point in any context, is making sure that we get accurate information about what the test is, the tested construct, in this case, mathematics, and trying to make sure that anything that may conflict with that and introduce construct relevant variance is controlled for. And in some cases, that's the way the test is administered. In some cases, that's the way students interact with the test. So it is an important point that that shouldn't be ignored as we're talking through this. So thank you for bringing that up.
Thank you, Leanne. What I'll do is I'll send your presentation as well as the video out to the community, and then as well as your email address. If people have any questions, they can contact you directly. And also, I see some new people who have signed on to the webinar today. So if you would like to join the community of practice, I'm just going to type my email into the chat box. My name is Deepa Shrikantaya. And if you would like to join the community of practice website, then you'll be able to access Leanne's PowerPoint as well as her video for this webinar today. I'm just going to ask one more time if there's any other quick questions. Otherwise, we're going to wrap up the webinar. Okay, I don't think there's anything else. So thank you so much, Leanne, for the presentation today. It was fantastic. And, I look forward to talking about or continue this discussion offline.